applications. So number 23, it says the value of the x-intercept for the graph 4x minus 5y equals 40 is. So we're looking for the x-intercept. Remember from the past 2 days, if we're looking for the x-intercept, we know that y is equal to 0. So if y is equal to 0, I can take my equation and plug 0 in for y. Because right now I can't solve this because I have 2 variables. But if I plug 0 in for y, I now only have 1 variable, which is x, and I can solve for that. So 4x, 5 times 0 is just 0, so it goes away. And then it's 4 times x. The opposite of multiplying by 4 is dividing by 4. 40 divided by 4 is 10. So we get x equals 10 for our x-intercept. Sorry, I didn't realize I cut that off at the bottom on you. Number 25. It says, on the set of axes below, draw the graph of the equation y equals negative 3 over 4x plus 3. Remember back to 2 days ago when we talked about graphing, they needed to be in y equals mx plus b form. This one is perfect. Then remember, you also need to list your m and your b. Your m is whatever is with your x, so my m is negative 3 over 4, and my b is 3. Remember, this is your x-axis, this is your y-axis. We always start with our b, which is our y-intercept. So I'm going to go up 1, 2, 3 on my y-axis. And then remember, this is either up or down. Because it's negative, it's down. And we always go to the right. So down 1, 2, 3. Right 1, 2, 3, 4. Down 1, 2, 3. 1, 2, 3, 4. You could keep going if you want. Obviously, that direction will go off the graph, so I'm going to go in this direction. So instead, I'm going to go up 1, 2, 3, 1, 2, 3, 4 this way, and up 1, 2, 3, 1, 2, 3, 4 this way. I'm going to use my paper as my ruler again because I forgot to get my ruler out. Put arrows on the end. Label y equals negative 3/4x plus 3. Now, there is a second part to this question. It says, is the point 3, 2 a solution to the equation? Explain your answer based on the graph drawn. Now, if you remember back to yesterday's lesson, we talked about plugging in or going to your calculator and all those kinds of things. But here's the problem with this one. It says based on the graph. So there was kids on the Regents exam that plugged this in for x and y like we always tell you you can. But because they didn't use any words about the graph, they didn't get full credit, even though they did all the work and essentially did more work than somebody else that got full credit. So we need to look at the point 3, 2 on the graph. 1, 2, 3, 1, 2. Here is the point 3, 2. Is that point on the line? No. 3, 2 is not a solution because it is not on the line. That is all you had to do to get full credit for this problem. If you would have plugged it in to check, you were fine with doing that as long as you said that it's not on the line. But if you didn't say those words, because they said based on the graph, you wouldn't get full credit. Number 27. I'm going to pick this up a little if I can and slide this under. 27 seems like a little bit of work for multiple choice, but it's really not that bad. It says the graph of a linear equation contains the points 3, 11 and 2, -1. Which point is also on the graph? So if we're talking about a line, a linear equation, and comparing 2 points, the easiest thing to do is to actually get the equation to the line. So if you remember back to yesterday's lesson, y equals mx plus b, we need our m and we need our b. So I'm going to start with finding my m. So y2 minus y1 over x2 minus x1. I'm going to label my points x1, y1, x2, y2. I'm going to plug them in, so my y2 minus my y1 over my x2 minus my x1. 1 minus 11 is negative 10. Negative 2 minus 3 is negative 5. Negative 10 divided by negative 5 is a positive 2. So in my equation, y equals mx plus b, I'm going to plug a 2 in for my m. So I have y equals 2x plus b. You can pick either pair of points. Sometimes mistakes happen with negatives, so I'm going to use this first one. So 11 equals 2 times 3 plus b. 2 times 3 is 6, so 11 equals 6 plus b. Subtract 6 from both sides, and we get 5 equals b. Oops, camera cut off a little bit of that. Let me slide that up for you. So I have my b value now. So my equation is y equals 2x plus 5. But we're not done because they didn't just ask us to write the equation. They asked us about another point that's on the line. Well, the easiest thing to do now is go to our calculator. Go into y equals and put in 2x plus 5 and hit second table. Now we could look at any points they wanted us to once we're in the table and we have our equation written here. But notice all of our multiple choice have 2 as the x value. So I just need to go down to 2x value and 9 is my y value. So choice 4 is the appropriate choice. On to the next page, number 29. So 29 is another short answer, and it's a higher point one because there's a lot of steps to it. It says, next weekend, Marnie wants to attend either Carnival A or Carnival B. Carnival A charges $6 for admission and an additional $1.50 per ride. Carnival B charges $2.50 for admission and an additional $2 per ride. In function notation, write a of x to represent the total cost of attending Carnival A and going on x rides. And in function notation, write b of x to represent the total cost of attending Carnival B to go on x rides. So I'm going to go down to the bottom and write part A. So my first equation is going to be a of x, and my second equation is going to be b of x. So Carnival A, in order to go there, they're going to charge me $6 plus I need to pay $1.50 per ride. And x is the number of rides. So $1.50 times the number of rides I go on. In order to go to Carnival B, they're going to charge me $2.50 to get in plus an additional $2 per ride. So notice, you know which one has to have the x with it because it says they're charging you per ride, whereas your admission, you only pay that one time. You're not multiplying that by anything. So that covered part A. Part B says determine the number of rides Marnie can go on such that the total cost of attending each carnival is the same. Use of the set of axes below is optional. So there's two different ways you can do this one. You can just solve it by algebraically by setting your equations equal, or you can graph them to see where they intersect. They give you a graph, but they don't tell you that you have to use it. Because we're graphing, I'm going to practice with graphing right now. So for part B, I need my m and my b for each equation. Remember, I kind of have these written backwards. The equation is y equals mx plus b. Remember, your m is always what's with your x value. So my m in this one is 1.5. But remember, we want a fraction. So go to your calculator. You can type in 1.5 math, and then the first one is fraction. And it will turn it into a, oops, the 1.5 didn't show up, 1.5 math fraction, and we get 3 over 2. So my m is 3 over 2 for the first one, and my b is 6. And then for the second one, my m, it's whatever's with my x, so it's 2 over 1, and then my b is 2.5. So now I need to go to my graph and graph them. So I'm going to start at 6 for my first one. 1, 2, 3, 4, 5, 6. if I go up 3 over 2, I'm only going to get one more point in the positive direction. Then I'm going to have to go in the negative direction. Is it going to make sense that rides are going to go in the negative direction? No. So we're probably going to want to change our scale on our graph. So I'm going to make each of these worth 2 instead of just 1. These down here, also I'm going to change to 2 so that way my slope doesn't get messed up. So 2, 4, 6. Then I'm still going to go up 1, 2, 3 over 2 boxes, 1, 2, 3 over 2 boxes. I'm not even going to go in the other direction, so when I connect my line, I'm just going to make it go this way, and I'm going to label that A of X, because we can't go in the negative direction for rides. When I graph this one, it's going to be a little bit harder. So 2.5 is right here, and then we didn't even go by whole numbers on here, so it's going to make it harder. My suggestion is to go to your calculator if you don't have a whole number for your b and make the calculator do it for you. So it's 2.5 plus 2x. I'm going to hit second table, and I'm going to look at my values in my table. So at at 0, we're at 2.5, which was about here. At 2, we're at 6.5, so 246.5, which is about there. At 4, we're at 10.5, so 2, 4, 6, 8, 10.5. At 6, we're at 14.5, so 2, 4, 6, 8, 10, 12, 14.5. So it looks like somewhere in the middle there they crossed. Is it easy to do this one based on the graph? Probably not. I can't really read where they crossed on there. So, I know it seems like a lot of work. Obviously, if it was your exam, you'd want an exact answer, so you need to find another way to get your answer. So, obviously, choosing graphing wasn't our best choice. So now, we need to do it another way. Well, we want to know when they're costing the same. So I want to know when this is equal to this. So all I have to do is set them equal to each other. The reason I am showing you both, though, is because sometimes it might actually be easier to graph. And a lot of you are really good at graphing, so I want you to know how to do the graphing just in case it would have been easier. So I'm going to get my x's together, so I'm going to subtract 2x from both sides. I get 6 minus 0.5x equals 250. Subtract my 6 over. I get negative 0.5x equals, just making sure you guys can see that still. We get negative 3.5 and divide by negative 0.5 on both sides. And we get x equals 7. So 2, 4, 6. So 7 was in the middle here, so it was going to be over here where it actually crossed a little bit. So it wasn't a spot where we even really could read on our graph real well. So the answer to this part is 7 rides, both carnivals, will cost the same thing. Marnie wants to go on 5 rides. Determine which carnival would have the lower cost. Well, this is nice that we already did graph it, because 2, 4, 5 is right here. Which carnival costs less at 5 rides? This one that we did down here, right? So B of X is the answer. So carnival B. And justifying your answer, actually the graph justifies it for you, so you don't have to do any more work. So graphing was a little bit easier for parts of it, and solving it algebraically was easier for other parts of it. Okay, on to the next one. Number 31. A local business was looking to hire a landscaper to work on their property. They narrowed their choices to 2 companies. Flourish Landscaping charges a flat rate of $120 per hour. Green Thumb charges $70 per hour plus $1,600 equipment fee. Write a system of equations representing how much each company charges. Determine and state the number of hours that must be worked for the cost of each company to be the same. The use of the grid below is optional. If it is estimated to take 35 hours to complete the job, which company will be less expensive? So I'm actually not going to graph this one because these numbers are pretty big, so I know I would have to do crazy scales down here. So we're going to do Flourish Landscaping and then Green Thumb. So Flourish Landscaping is charging $120 per hour. So 120 times X, however many hours they work for. Green Thumb is charging $70 per hour, plus they're automatically charging you $1,600 just for bringing their equipment there. So that's our system of equations. Then they want to know when the cost of companies will be the same. So just like the last one, we could have graphed them and see where they intersect, or we can set them equal to each other. So 120x is equal to 70x plus 1,600. I'm going to subtract my 70x to the other side. So 120 minus 70 is 50x equals 1,600. And then 1,600 divided by 50 on both sides, we get 32. So 32 hours, if they work, each company would cost the same amount of money. If it is estimated to take at least 35 hours to complete the job, which company would be less expensive? So this is how we could have done the other one if we wouldn't have graphed it. You can plug in. So if I take my first equation for Flourish Landscaping, $120, oops, sorry, gotta move this up again, $120 times 35 hours. So in your calculator, 120 times 35, it would cost $4,200 with them. To use Green Thumb, it's $70 times the 35 hours plus 1,600. So 70 times 35 plus 1,600, it's only $4,050. So Green Thumb would be cheaper. And justifying your answer again is that work that I showed. If we would have chose to graph them, you wouldn't have had to do this. Hopefully on your graph you would have been able to see where they cross at 32. And then also you would have been able to look over at 35 like we did on the last one and see which one is cheaper. So if you're better at graphing, by all means do the graphing. If you're better at algebraically, by all means do the algebraically. One more to go for today. Number 33. Bring this back down so we can read it. Central High School had 5 members on their swim team in 2010. Over the next several years, the team increased on an average of 10 members per year. The same school had 35 members in their chorus in 2010. The chorus saw an increase of 5 members per year. Write a system of equation to model this situation where X represents the number of years since 2010. Graph this system of equations on the set of axes below. So you have to graph this time because they don't give you an option. They're telling us X is years since 2010. So this is 0, 1, 2, 3. We can still count like that, but this really means 2011, 2012, 2013. And then obviously our Y value is the students over here. So first of all, for the swim team, we have, so I'm going to say Y equals, we have 5 members to start on the team, plus we're getting 10 new members each year. In chorus, they started with 35 members, and they're only getting 5 new members each year. So for this equation, my M and my B, remember your M is what's with your X. So my M is 10 over 1, and my B is going to be 5. For this one, my M is 5 over 1, and my B is going to be 35. because we have such big numbers and we're dealing with lots of 5s and 10s, I'm going to count my students by 5s. So 5, 10, 15, 20, 25, etc. So when I start my B, I'm going to start at 5 right here for this one. And then be careful, you're going up 10 over 1. So up 5, 10 over 1, because these are still counting by 1. Up 5, 10 over 1. Up 5, 10 over 1. Up 5, 10 over 1. So I know I'm only going up 2 boxes, but remember, each box counts as 5. So up 10 over 1. Up 10 over 1. I'm going to hope that that's enough. I should have used a ruler for that. I'm going to call that swim. Then when I do chorus, I'm starting out at 5, 10, 15, 20, 25, 30, 35. They're only going up by 5 and over 1. So up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1. Oh, look at that. Perfect, the last point that I had plotted. So I'm going to connect that and call that chorus. So that was all I had to do for the top part of the directions. It just said to graph it. On the bottom it says explain in detail what each coordinate of the point of intersection means in context of this problem. So if I look, that's where it is on my x-axis, that's where it is on my y-axis. So let's count. 1, 2, 3, 4, 5, 6. So in 6 years, which would be 2016, there will be, sorry, I probably gotta move that up a little bit more. There will be, let's count, 25, 30, 35, 40, 45, 50, 55, 60, 65 members in both chorus and swim team. It is your job for homework tonight to do numbers 22 through 32 even. I know these are a little bit more difficult because they are the Regents questions. Try your hardest. If you have questions, email me.